Welcome everyone to this 2024 seasonal update webinar for the Western region being presented to you by the Australian Fungicide Resistance Extension Network, also known as AFREN. I'm Bridget Penner from Ag Communicators, and in today's session we're pleased to have leading experts in cereals and pulses in the Western region here to present this update. First up, we'll hear from Dr. Kith, Jayasena, a research scientist with WA's Department of Primary Industries and Regional Development. Kith is based in Albany and covers the Great Southern region. Then we'll hear from Andrea Hills, also a research scientist with DPIRD. Andrea works across cereal, pulse and oilseed crop pathology and is based in Esperance. AFREN is a GRDC-supported initiative that provides up-to-date resources and information directly to Australian growers, agronomists and advisors. You can find resources including fungicide resistance management guide, webinars, fact sheets, podcasts and more at afren.com.au. Before we begin, just a brief bit of housekeeping. If you have a question during today's webinar, please use the Q&A box to ask your question, and we'll aim to cover these at the end of the session. So now I will hand over to Kith to present. Thanks.
Thank you, Bridget. Today's presentation will be 2024 season and outlook, disease presence in WA this season. And then Andrea will take over from there and talk on focus on barley loose mud, late season disease management and WA fungicide resistant update. Now, this is one of the important things in the plant pathology. To have a disease should have a host, and that host should be susceptible. Then pathogen should be there, a pathogen which infect that host. Then the environment, what are the environmental conditions required for that pathogen to infect the plants and produce the disease? Example, I have taken as host as RTG planet, is a susceptible variety. Then the pathogen should be net form net blotch. The environment requirements, prolonged wetness, high relative humidity, and temperature range. So the first couple of slides will be, since the crop has been already in the ground, and the driving force for disease management is controlled by the environment. Let's check seasonal rain and temperature for 2024. We say the rainfall is early June, July dry, and August rainfall was till then is below average rainfall. The temperature wise, the maximum minimum temperature is above average. So it was warm condition till June, July. So when it comes to August, more wet in the south, coast, south area, and above average for northern part. The green bars is about 125 to 150%. The blue ones is over 300%. So it was wet August. Let's go into September. This is where we are more interested. What is going to happen now, from now till the harvest? So you can see in the left picture, it's all more rain is there. The temperature, chance of exceeding maiden temperature minimum is above average, and maximum also above average on the right hand side corner. So that means it's going to be warmer than normal for the whole period for September with rain. When it comes to October, the rain will be gradually reduced. It will be about average, and rain temperature will be average. Maximum temperature will be above average. So it's warmer than normal. Very temperature minimum maximum will be very similar to September. So how important these environmental factors? This slide presents the finding of 2 trials conducted in 2022 and 2023 to examine the impact of weather conditions on the progress of net form net blotch. The trial employed spore trapping to determine the spore movement and to correlate that with the disease progress, with the aim to provide data input for the net blotch decision support tool. So the two colors, 2022 is blue, 2023 is red. The top row indicates how the disease progress, August, September. The second row indicates the rainfall, millimeters for that period. Then the third row, weekly rainfall. And the fourth one is how the spore movement, the temperature during that period, maximum temperature and minimum temperature. So if you take into account, compared to 2022 to 2023, there were plenty of 2022 was epidemic and 2023 was not epidemic, just bare minimum disease was there. So if you analyze the rainfall for 2022 to 2023, it's very similar, but only difference is number of rainy days per week. So more rain events had 20 days rain events had in August month compared to 2023, which was 12. So what do you get from out of it? So weather conditions strongly influence the disease severity. Number of rainy days rather than total rainfall is important. Temperature rainfall conditions influence the latent period and infection establishment. So what diseases we have seen in 2024 till this moment? We have seen net blotch, net form net blotch, then spot form net blotch, net form net blotch widely seen in RTG planet. Spot form net blotch we have seen in Maximus, Spartacus, and Buff. So what happened from here to springtime? It already started. This is a warm loving fungal pathogen. Normally, to see the disease, there should be leaf wetness, high relative humidity, and the temperature between 15 to 25 degrees. Then the latent period will 10 days. So it will roll in if these conditions, then the more fungal spores will produce and infect the crops. Then comes to powdery mildew. Powdery mildew is something we should be concerned with. We got the resistance for mildew. We have seen mildew on Maximus, Sale, Maximus, and Roslyn. Roslyn we have seen in South Sterling recently. And those mildew and the net blotch we have seen in the spore traps. Then the biggest issue for this season is detecting loose mud than normal, especially in Neo. The reason for that is probably the bulk of crops would have been seen infected with the loose mud spores. Now we see a lot of loose mud across the south coast. So if the crops are flowering at this stage, they will be prone for loose mud infection. More detail, Andrea will speak about. Another disease, early stages when the temperature is low, we have seen barley scald on Leporus, then Maximus. The one in the right holding the leaf sample, that is how Leporus was infected in 2022. It's really bad when it is got going. And there are two strains, which one is infecting Maximus. Now the disease have, because it started to get warm up, it has started to slow down. The conditions for that is, it is very important to have the leaf wetness, high relative humidity and low temperature. This is mostly less than 20 degrees, 10 to 20 degrees temperature will be more conducive for this pathogen to go. When it gets warm up, the symptoms will be there, the progress will be very bare minimum. Now get back to wheat, net form Septoria nodorum blotch and yellow spot. These two diseases have come as mixed infection. Have seen in Kensai, Vexen, Septoria, and Caliber. And it also, if its rain events continue, more than the research which has done long time ago by Jet Patel and Rob Lockman, the requirements is to have 10 millimeters of rainfall to start increasing the disease for that spring season. Then the low barley powder mildew, wheat mildew, we have seen Vexen, Scepter, Valiance, and you can see especially in the south of Great Southern and South Coast mildew coming up, and it needs that high relative humidity, but too much of rain will reduce the infection. And the temperature goes above 25 degrees, it will tends to reduce the infection. And the other one is leaf rust. Leaf rust is in Brumby, as seen in the central region, and it's a warm-loving pathogen. When it gets wet, leaf wet, which can be due to dew, frost, or any other means, and with warm conditions, it will generate more spores and more crops, susceptible crops will be infected. Other one is flag smut. We have seen in the up north. It is a soil-borne, seed-borne pathogen. I believe Andrea will talk about how its effect comparison between the loose mud. Then comes to mildew. Downy mildew we have seen very early stage. Now don't see it needs the wet condition. And the blackleg. Blackleg is one of the issues, but up north, most of the north and the south and the center, most of the crops have been sprayed with fungicide, 20 to 50 stage. It can be possibility to get infected pod infection because we still see in spore traps a lot of blackleg ascus spores. It needs high relative humidity and the temperature between 13 to 18 degrees. Latent period will be about 5 days. So if it's wet, we anticipate to get that since the crop has been sprayed early, but there is a possibility of getting pod infection this season. Then the Sclerotinia of canola, it started to come up. The crops have been sprayed. Some have not sprayed for Sclerotinia, but if they have sprayed after canopy closure and moist soil can conducive for to infect the crop, stem infection. Similar to pod infection on lupins, very similar conditions, both are infected by the same fungus. So to have the pod infection, should have 11 to 20 degrees and high relative humidity and wet condition. Apart from that, we have seen on canola, turnip yellow mosaic virus, and lupins, bean yellow mosaic necrosis, and recently we have seen the botrytis gray mold on lupins. Now I hand over to Andrea. Thank you.
Hi everyone, thanks Kith. So now we're going to concentrate on barley loose smut for a couple of slides because as Kith mentioned, there's a bit around. There's also a bit in the new variety Neo, and growers are sort of saying, oh, what's going on? So the first point to make is that variety susceptibility does vary. We've done trials in the past at DPIRD where we've compared the variety susceptibility to loose smut, and we've found that the high marsh family of varieties tends to have more smut than other varieties. Unfortunately, we haven't done any recent comparisons, so we can't tell you where Neo sits in this spectrum of susceptibility. The good news about loose smut is that the yield losses are generally fairly low, and they're proportional to the percentage of plants that are infected, not just the tillers, just the percentage of plants that are infected. And given that you've got over 100 plants per square metre, you'd have to have at least one smutted head every square, or one smutted plant, I should say, every square metre to be even approaching 1% yield loss. But that's not really the point. Loose smut's a really ugly disease. The good news is that it looks worse than it normally is, but we don't want to let it get out of control until it is at a point where it can affect our yield. So one aspect of why we're seeing a bit more loose smut this year is because of the seasonal conditions. And that's because at seeding, with our very dry start, that reduced the ability of the seedling to be able to take up enough fungicide to stop any loose smut infection that it had from reaching the growing point and expressing. So it's not that your seed dressing has failed or that smut has suddenly become resistant to the fungicide. It's just those seasonal conditions were a little bit less than desirable for fungicide uptake. Now in spring, about this time of the year, the spread of loose smut is definitely enhanced by a cool, wet spring. And that is one of the reasons why we tend to see more smut in the medium to high rainfall areas, because those areas get more suitable conditions for transmission. So in barley loose smut, as I've said, we have, well, maybe I haven't said, the grain is basically completely replaced by the dark brown powdery spores. The heads will start appearing a little bit earlier usually than the rest of the crop, and they have a really thin membrane over them. That membrane ruptures and the wind will spread spores onto neighbours, and the wind will also carry them along further. The good news is that in DPIRD trials, we've tested a whole range of seed dressings, and we found them all to be effective. They'll all reduce smut, but we do know that the SDHI seed dressings are a lot more effective than most of the other groups, regardless of the product we trialed. So there's, you know, that's really good news. And the fact is that we're treating loose smut to prevent the expression of smutted heads. Now, when we're talking seed dressings, we need to keep our performance expectations of the seed dressing realistic. In our trials, we had a really heavily infected seed lot, and we got close to 100% control of loose smut. But growers out there, you're controlling, you know, over 1 million seeds per hectare. It's not going to be surprising that a few escape and produce smutted heads. So even if you do get good application, which is the critical step or the second part to sort of controlling smut, number one is using the seed treatment, number two is getting good application, but you will still see the odd escape in your crop. And it's not about completely eradicating smut. It's about getting it down to that, you know, just that odd head. If we have a look at the life cycle now, so we're at this point on the left where we can see smutted heads in the crop. And as I said, they're blowing those smut spores onto their neighbours and infecting that developing grain, even though they may be only flowering. The spore lands on the flower, grows into that embryo, and it sits there dormant. So at the top of the life cycle, you come along in the harvester and harvest your seed crop. Hopefully you'll clean and grade it, and if you have a good look at the seed, it doesn't really matter. You can't tell whether there's loose smut in there or not because it's carried internally, as I said. And at the down the bottom here, that fungus just lies dormant in that embryo until it starts germinating, and then it grows into that tiny little growing point. And at the stage when the head's still an embryo, it invades the head and starts replacing what would become grain with the hyphae of the smut fungus to produce and ultimately that smutted head that emerges. So the seed dressings act down the bottom here. They interrupt that life cycle, prevent the loose smut developing enough to get into the embryo, and so that plant can still go on to produce a normal head. Okie doke. So next slide. I thought it'd be worth mentioning the other cereal smuts and bunts that we get in WA, and they're all readily controlled with a seed treatment. Over here on the right, I've put some more pictures of wheat flag smut. It affects not just the flag leaf, but other leaves, and also on the very right, you can see a plant where it's infected the stem as well. And that's because we're seeing a bit more of that in the last few years in quite a few areas of the wheat belt. And one reason for this is that the newer varieties seem to be more susceptible for flag smut, in particular variety Rockstar. In any case, the takeaway from this table is that the transmission of loose smut is different. It's inside the seed, but the others are external. They're carried on the seed coat, or they stay in the soil and infect grain there, or it's carried on contaminated machinery. In terms of being transmitted externally, down the bottom, the little photo that's popped up, so that's a barley embryo from a barley grain. And what we've done is stained it so that these blue bits, you can actually see the smut that's inside the embryo. That's just sitting there dormant, ready to go, unless you've got a seed dressing for the seed to take up and stop that smut invading the juvenile growing point. Okay, so thank you. Barley loose smut, what you can do from here? Well, unfortunately, at this point of the season, there's probably not a lot you can do, but you can start planning for next year. So have a look around at a seed dressing that suits your needs, because obviously some of them have insecticides with them, some of them have foliar fungicide activity. It's worth pointing out that the Inforo products aren't effective against barley loose smut. And next year, if you've got a seed crop and you want to try and really get those levels down very low, then just as heads are emerging from the boot, you can try applying tibuconazole, and that'll reduce infection. That isn't a replacement for using a seed dressing, but it's just helping to further decrease the incidence of smut in the seed. And keep in mind that, as I said, your seed dressing is doing a good job, even if you don't realise it. If you've applied it nice and evenly, I know, you know, if you're using an auger at seeding, you're in a rush, but take the time and apply it nice and evenly, and just moderate your expectations. You won't completely eradicate it in susceptible varieties, but you will be able to really get it down to minimal, really low levels. Okay, we're going to move on to just the foliar disease management now. So at this point of the season, we're getting into the second half. Most crops well, many crops are flowering or even grain filling, but we do need to have sort of revisit the yield potential in terms of the season having started late, or the crops that did come up early, some of them are very patchy, the plant numbers aren't there. So relative to other seasons, we're not really, in some areas, going to be hitting our maximum potentials. Have a look at your crop growth stage and how long is left for the season for you, for where you are. The outlook generally is supposed to be warm and wet, but having a look at the weather predictors, next fortnight's going to be fairly dry, and the weather may be your best fungicide and definitely your cheapest one. If you're not sure what you're looking at when you are in the paddock, and that's important, obviously, if you're going to go in with a fungicide, you want to know that it's effective against what you're seeing. And we do see a lot of the physiological markings on barley, and in wheat we're seeing some false black chaff around the place. So that's the discoloration underneath the peduncle, and sometimes it goes up onto the head. So it can be mixed up with Septoria nodorum, or nodorum blotch, I should say, as well. And if you're unsure, get in touch. We can help you work it out. I guess one of the final points is prioritise the crops you want to manage. Sometimes the ones at highest risk, well, they're a good canary in the coal mine. Monitor these guys pretty heavily, because they may be the ones that need the most protection, and they'll give you a heads up on what might be happening in other crops in a few weeks. So foliar application for wheat, the target is to protect that upper canopy, because they're the ones doing the heavy lifting when it comes to grain filling, especially the flag leaf. The best application is obviously for that flag leaf emergence. That's well past now, and hopefully you've managed to get that on in a timely fashion. Your flags are nice and green, job done. If you're in the very high rainfall areas or you're seeing some gloom blotch, you may reconsider whether or not you want to go back at air emergence to protect those heads. And if yellow spot's your enemy, well, DPIRD have put out this app. You can see a little decal of it on the right here. And that's yellow spot decision tool, where you can, it's very simple to use. You put in crop details on your specific paddock conditions, yield potential, and fungicide options you might look at using, and it will give you a likelihood of what your economic return will be. And finally, I want to mention wheat leaf rust. As Kith highlighted, we did see some wheat leaf rust around the place in Brumby earlier this year, and a lot of our varieties are actually quite susceptible to leaf rust. It's one of those diseases that even up to flowering we want to keep an eye on and manage, and particularly in those susceptible to very susceptible diseases, Brumby, Vixen and Devil. And if you want to get a heads up on whether there is leaf rust around, the DPIRD's e-newsletter Pest Facts is a really good way to stay up to date with what's being found around the place. Agronomists and growers are welcome to make reports. The more information we have, the better. It'll help you keep on top, because wheat leaf rust would definitely be flagged. Fungicide application for barley is very similar in terms of wanting to protect that upper canopy, but it is a little bit different because that flag is generally fairly negligible. So we're trying to protect the two leaves under that, flag -1 in particular. Now, depending on where you are, you may have already applied a foliar fungicide at early stem extension, and often that's all you need. But in other areas, especially the long rainfall, high rainfall areas, two-spray strategy, 3 weeks apart, is quite a common and very effective way to manage the foliar diseases. Physiological spotting is notorious in barley. So if you're seeing something, it doesn't really look like spot form, or it doesn't really look like net blotch. Oh, is that funny one scald? No, it's not that. Or even if you're just not familiar with scald, send someone a photo, an agronomist or DPIRD, and we'll try and help you work it out, because it doesn't respond to fungicide. You'll be wasting your money. Okay, Bridget. So your take-home messages are basically what I just said. Get on top of those, figure out what you're actually trying to control. Have a look at your seasonal outlook. Do you need to actually use a fungicide, or is it probably going to warm up? You know, you might get a little bit of disease development, but it's not going to swamp out those upper canopy leaves, so let's leave it. Plan now for 2025 for things like loose smut, based on what you're seeing now, or for if you are worried about something like wheat leaf rust, might want to have a look out for a different variety. And so while you're out there at your spring field walks, keep an eye on those new varieties and see what's out there that might make your life, in terms of disease management, a lot easier to deal with. Okay, so we'll move on to fungicide resistance and those. And I'm just going to start by putting out this slide, which sort of shows what our colleagues at CCDM mean when they refer to sensitive, reduced sensitive, or resistant disease strains that are out there. So at the top, what we've got here, what we're looking at, is an agar plate that has had fungicide mixed into it, and then sections of diseased leaf are put on the plate. And you can see at the top that the sensitive disease just simply doesn't grow on the plate. The fungicide's doing its job. The reduced or less sensitive pieces of disease are actually able to survive. They're not doing particularly well, but they're still there. And finally, at the bottom, we can see those pieces those diseased bits of plant are actually just merrily growing along and quite happy. So if you imagine that on a microscopic level, this is your leaf, well, you go out there, you've got all these spores landing on your nice wet leaves. The fungicide you applied last week could be doing one of these 3 jobs. And the fact is that if you've got growing a really susceptible variety, you've got a whole lot more of these spores. So your chances of getting one of these reduced sensitive or resistant spores is a little bit higher. That's why we try to use our integrated disease management to reduce the population. And we also want to know where these guys are at. That's why we keep doing these and encourage you to get out there and submit leaves to CCDM, so we know where we're at with these populations. And hopefully these guys, the 2 reduced sensitive and resistant, are just a tiny proportion of the population. Okay, next map. This is a very, very complex map. And basically what I'd like you to take away is that the WA on the left has, go back up, please, Bridget. We have circles indicating barley resistance issues, triangles indicating canola resistance issues, but over in the eastern states, you'll notice that they also have squares. So they have wheat resistance issues that we don't, and it makes their life pretty hard. So you guys are doing a good job in wheat. So far, you've managed to avoid resistance issues in that. Let's keep it like that. So next slide now. If we concentrate on WA, I've just highlighted the ones that we do know that we've got here. Barley powdery mildew, and both the net form and spot form net blotch. And we also know that blackleg in canola has some reduced sensitivity. If we have a look at the next slide and the table there, this is showing a similar amount, similar information, except that it does it so that it shows you the fungicides that are affected. So at the top of the table, we've got barley powdery mildew. Barley powdery mildew. We've known for a while that we have resistance to the older generation DMI fungicides. And then if we look at net blotches, both net form and spot form, unfortunately, we have resistant and reduced sensitivity strains out there in the paddock that are not only against the older GMIs, but also some of our newer products like prothiaconazole and epoxyconazole. And that's of concern to us because they are just so valuable in our system. In terms of canola blackleg, it's a similar story in that there is reduced sensitivity to both the older and some of the newer DMIs. If we look at the group 7s, it's basically that both the net blotches have evolved to have some strains that are resistant or less sensitive to fluxapyroxad. Okay. So they're on, yep. Okay, so if we have a look at our net form net blotch, you'll see that we have a high number, unfortunately, in the big pie graph, a high number of resistant strains that have been identified, and that a lot of these are concentrated on the lower, on the southern areas. It's really good that growers have moved away from Planet, because you'll see a lot of this testing, well, all these maps that I'm going to show you have been done over the last 10 years. Hopefully we've moved away from Planet, which had turned into a bit of a sucker for net form with the pathotype change. And it's really important for these, if you see any net form net blotch, to try and get in a different fungicide group than a DMI, even if it's not your primary target. Next slide, please. So net form, in terms of the SDHIs, the good news, I suppose, is that it's reduced sensitivity more than resistance, but that's still a heck of a lot of different strains in the population floating around out there. And it's a similar story. We want to use something that is from a different group. Given we have DMI issues, I guess Astrobi is a good answer if you've got net form to try and really mix it up. That should be controlling these reduced sensitivity ones that have SDHI reduced sensitivity or a DMI reduced sensitivity, and get on top of those populations, prevent them, make sure that they're just a tiny part of the population that's out there. Okay, so on to spot form net blotch and DMI. So this is our most widespread disease in WA, and you'll see that we've found a mix of, or CCDM found a mix of resistance and reduced sensitivity for DMIs. And basically, if you look at the distribution, these issues are found wherever barley is growing. And I guess that this is a good call out that everyone's got to play their part in this. It's not just on high rainfall people, it's also low rainfall. The other part of it is that for growers, especially in the medium to low rainfall areas where there've been a lot of propiconazole use as a standalone product, I think that can't go on, basically. And I know a lot of people will swap to Prosaro type products now that they've come down in price a lot. And while there are two different fungicides in there, they are both DMIs. So using that year in, year out is also far from ideal. Once again, you need to rotate with a different group, not just a mix of maybe two DMIs. And it's like Professor Powers from, ARI and herbicide resistance used to say, if you're onto a good thing, don't stick to it. Okay, thank you, Bridget. The spot form net blotch resistance to SDHIs is primarily in terms of reduced sensitivity, but it is a mixed bag in terms of where it occurs. So another good message there about everyone, whether you're in the low or the high rainfall areas, trying to mix it up, trying to avoid those sucker varieties so we can keep these reduced sensitivity populations down to the absolute bare minimum and extend the life of our fungicides. So that brings us to our integrated disease management strategies, or IDM, to manage fungicide resistance. Variety selection down the bottom, so that is your very foundation of keeping disease pressure at a really manageable level. If you've been growing a susceptible or very susceptible variety, even moving up to a moderately susceptible variety is a step change in terms of reducing that disease pressure for you. And if everyone mixes it up also at a community type level. Realistically, we know we're never going to have an ideal variety that is high yielding and addresses all our disease resistance needs. So when you're looking at a variety, know what its weaknesses are, so that when you're out there monitoring, you say, oh, well, my variety is great for everything. Okay, Brumby, for instance. Brumby's great for this, that, great for mildew on the south coast. That's why we're growing. Some people are growing it. But the weak spot is rust. Okay, I need to be out there. That's what I'm keeping my eye on, because I know that any disease in Mother Nature, that it's going to take that chance to pop up, especially on an SVS variety. So know what you're dealing with and keep an eye out there. The second part, or the middle part of the disease management strategy, is about cultural methods, that basically anything non-fungicidal that will help reduce the disease pressure. So here we're looking at, your rotations, time of sowing, managing your stubble load or your green bridge. You can also get secondary, or as a secondary sort of support role, the plant nutrition will help you avoid disease. If you're in a sandy soil, they're pretty notorious for, potassium levels could be anywhere. They don't have to be really high to get good disease management, but if they are low, marginal or low, we have seen instances where that gives disease the edge in getting into the crop and causing infections. Another nutrient to be aware of is nitrogen. If you really put on a lot of nitrogen and you end up with a very lush crop, you can expect something like a mildew, unless you've got full resistance, will come in and exploit that. Mildew loves high nitrogen crops. So if we look at the peak of the apex of the pyramid, well, they are fungicides, and the equivalent in the food pyramid is the treats. These are supposed to be consumed sparingly. But the fact is, in today's world, we do use them. So let's use them wisely. Apply mixtures of your fungicide groups, ideally mixtures with different modes of action. Okay, and use your at least your minimum label rates, no discounting, and crop monitor so you're getting onto issues in a timely manner. And I hope that I haven't discouraged you with some of those slides earlier, but many of you growers are already doing the right thing. So keep going and you'll keep this under control. Okay, next. So the fungicide resistance 5 have a similar message around integrated disease management. So which is basically don't leave it all up to fungicide to do the heavy lifting. So because they are going to be under pressure because the diseases are dynamic and they're always shifting. So avoid the sucker varieties, rotate your crops, use non-chemical methods, and apply fungicides strategically using a mix of groups. And then hopefully we'll keep this enough under wraps that our next generation of growers have access to cheap fungicides as well. That is where I'd like to leave it. I'd like to say thank you to you on behalf of Kith and I for listening in today, and thanks for Bridget, who works in the background but keeps things running smoothly. And thank you to Fran Lopez from CCDM, who's on hand for all your tricky fungicide resistance questions. I'll leave them to him. Thank you.
Thanks, Andrea, and also thank you to Kith. That was great presentations. We have had, and I did forget to mention at the beginning that Fran Lopez is online as well. So if you do have any specific questions, please feel free to fire them at Fran. But we have had one question come in, and I might direct this to you, Andrea. And the question is, do other foliar fungicides have the same activity as tebuconazole on loose smut? If growers are going to be applying fungicide for foliar disease at the same time, it would be good to cover both, but tebuconazole is not the best on foliar diseases.
It's certainly not. It's also not recommended as a standalone for fungicide resistance reasons, and that's definitely why it should be kept to seed crops only. However, Kith is actually the one who did the work on this, and he'll be able to tell you himself. You'll hear from the horse's mouth whether something like Prosaro is actually a reasonable substitute or not.
If you are more concerned about the tebuconazole, we use in that trial was to see, because the Rexil is a seed resin, and active was tebuconazole. So we thought whether we can use that tebuconazole as a foliar, which was available to control. So by targeting when the infection process happened, which is more sensitive time is the flowering time, we managed to reduce the infection level. But so if you can't find the tebuconazole, The other option will be using Prosaro. Prosaro is at the moment, it is the registered product to use in most of the foliar diseases, though it got to be console at the moment. So if you use Prosaro, that will be dual purpose, not only tackling the loose mud, other diseases also, which say for net blotch or scald can be used. But I wonder, this is just thinking of there are 100% efficient SDHI products available as seed resin, and those products also available as foliars with some mixtures. Probably they might work, but I don't know. Till we experiment it, we can't go beyond that point.
Great,
That's
thank
all
you. Yeah, that's great. Thank you very much, Kith. Thank you both. I think we might wrap it up there unless there's any other questions that anyone has. But if you do have other questions, please head to the AFREN website. All the contact details are there. And again, a huge thank you to Kith and Andrea for sharing your insights and expertise on today's webinar. I've just posted in the chat box a brief survey. If you could please take the time to give us your feedback, that would be very much appreciated. On behalf of the AFREN team, I'd like to thank each of you for joining us today. We hope it was useful, and we look forward to seeing you at another AFREN event in the very near future. Thanks, everyone.